Okay, end of chapter exercise. End of chapter exercise. We are going to do it now. Question number 1. Convert the following rational numbers in the form of terminating decimal or non-terminating decimal. Okay, either it's going to be terminating decimal or non-terminating repeating decimal. So whichever the case may be, by the process of long division. Okay. So we have to do the long division. After getting the decimal, you have to check whether it's a terminating decimal or non-terminating repeating. So terminating means it will be having end. There is no end, but it's repeating means non-terminating repeating. Okay. So let me first one. Okay, 3 by 50. Okay, 3 by 50. If you are just dividing 3 by 50, okay, you will be getting the answer as 0.06. Okay, division, I hope everyone know it. 3 by 50. Okay, 3 by 50. So the answer is we are getting a 0.06. 0.06 is terminating. Okay, this is terminating. Terminating means it's having end. Okay, it's having end. Terminating means it's a rational number. It's the next one, 2 by 9. So same as you have to divide 2 by 9. If you are just dividing 2 by 9, so the answer is 0.2222 is repeating. Okay, so 0. That is 2 by 9. The answer is, if you are dividing 2 by 9, the answer is 0.222. So repeating. Now this is non-terminating but repeating. Okay, non-terminating, repeating. Okay, non-terminating, repeating. So division and all you have to practice it. Second question, prove that root 5 is irrational. Okay, root 5 is irrational. Okay, so in the previous class itself we have proven root 2 is irrational, right? Root 2 is irrational. Those who are missed the class, right? You can just have this recording. Here I have proven root 2 is irrational. What you have to do? First will be giving proof by contradiction. Contradiction. First you will be just taking root 2 is rational. Rational means it can be written in the form of p by q. Q is not equal to 0. P and q are integers and co-prime. Co-prime means p and q are having only 1 as a common factor. That is a condition for co-prime. Okay, here we will be proving P and Q are having more than one common factor as 2. Okay, for proving this, first you will be squaring on both the sides. Okay, while squaring, root 2 square it will become 2, P square by Q square. Then interchange the digits, right? Q square is equal to P, 2 will come here, P square by 2. That means 2 divides P square, therefore 2 divides P also. If 2 divides P, P is the multiples of 2. So P can be written as multiples of 2, 2k. K is an integer. Now in the place of P, I have to substitute 2k in first equation. Just substitute 2k. So expand, simplify. You will be getting again k square is equal to q square by 2. That means 2 divides q square, therefore 2 divides q also. From this, what we can say means P and Q are having 2 as a common factor. Actually, in the beginning, we have taken P and Q are co-prime. The common factor only 1. But here we have proven 2 also common factor. Therefore, this is giving contradiction. Our assumption is wrong. So, root 2 is irrational. The same thing, we have to prove it for root 5 is irrational. Okay, root 5 is irrational, right? So why I have taken the same image means we are going to replace the number. So first step, let us assume root 5 is rational. If it's root 5 is rational means root 5 can be written in the form of P by Q. P and Q are integers, Q is not equal to 0 and co-prime. Now next, okay, squaring on both the sides. Okay, squaring on both the sides. So if you square root 5 square, it will become 5. So P square is P square, Q square is Q square. Now just interchange. 5, you just take this 5 to this side, q square to this side. So 5 it will come here. Since 5 divides p square, then 5 divides p also. If 5 divides p is the multiples of 5. So p is the multiples of 5. So 5 into k is an any integer. Now I have to substitute p is equal to 5k in equation number 1. I have to substitute. In the place of p, I have to substitute 5k. Just substitute q square is equal to 5k the whole square just divided by 5. Now 5 square is, you will be getting as 25. K square is k square just divided by 5 square is, so here divided by 5. Now we can cancel 1 5s are 5, 2 5s are 10. Sorry, 1 5s are 5, 5 5s are 25. So I'm just getting balance as 5k square. 5k square. So q square is equal to 5k square. Now you take this 5 to this side, so it will become division. Q square by 5. So 5 divides q square. Therefore, since 5 divides q square, then 5 divides q also. So P and Q have 5 as a common factor. So this gives contradiction. Why? Because P and Q are having co-prime number. Co-prime means that should have only 1 as a common factor. Here we have proven 5 also common factor. So our assumption is wrong. Root 5 is irrational. Okay, root 2, root 3, root 5, root 7, everything is the same. Only the number has to be changed. Okay, this is very important question in grade 10th, first chapter. Okay, you also can check. Question number 3. Convert the following decimal numbers in the form of p by q. Okay, so decimal is given, you have to write in the form of p by q. Now, first question 12.6. Okay, now this is terminating. Terminating means it's very easy to write p by q format. Okay, first question. So 12.6 is given. Okay, how many decimal part? As many zeros you divide, so you'll be getting the answer. Okay, so 12.6 means we can write it as 126 divided by, here we have 1 decimal point, so just divide by 10. So 126 by 10 will be getting 12.6. Okay, so we have written in the form of p by q. If you can able to simplify, means just simplify and write. So both can be simplified with 2 table. 6 2s are 12, 3 2s are 6. Now 5 2s are 10. Okay, 63 by 5. Okay, 63 by 5 is the answer. Second question, 0.0120. Okay, now we have to write it in p by q format, as this also having terminating decimal having n. So as many decimal part, as many zeros you divide. Okay, so if you are just writing this, how we can write? 120 divided by, we have 4 decimal part divided by 4 zeros. 1 2 3 4 zeros. If you have any doubt, it's just convert and check. If you are dividing by 4 0, you have to keep the decimal point before 4 place. It's coming correct. Yes. Now I can just simplify this. Okay, 0 and 0 will get cancelled. 12 by 1000. Again, I can just simplify with 2 table. 6 2s are 12. Okay. Now 2 table means 5 2s are 10. Okay. 0 0. Again, we can just simplify with 2 table. 3 2s are 6. Okay. 2 table means 2 2s are 4. Balance 1. 5 2s are 10. 0. So 3 by 250. Okay. This is very simple, as they are having terminating decimal. Okay, now we just come to the third question. Okay, third question. Okay, so we have to write 3.052. The same what we have done before. Here only 2 digits are repeating. Okay, 2 digits are repeating, and this is repeating decimal is not coming immediately after the decimal point. Okay, it's not coming immediately after the decimal point. So this type of decimal is called as general repeating decimal. Anyway, as two digits are repeating, you have to multiply by 20. That is 100 I have to multiply. First step, just take let x is equal to 3.052. Okay, 52 is repeating. 052. Okay, 52 dot dot dot. This is first step. I can just take it as first equation. As only two digits are repeating, so I have to multiply by 100. Okay, multiply by 100 into x is equal to 100 into 3.05252 dot dot dot. Multiply 100 into x is 100x is equal to, if you multiply by 100, the decimal will move towards right side 2 place. Okay, right side 2 place. So you'll be getting us 305.252. Once again, you check after the decimal point, we should have equal number of decimal part. Here I have only 3. Here I have only 5. Okay, so I can just repeat 5 to once again. 5 to. Now it will be equal. Here also 5, here also 5. This will be easy for the subtraction. Okay. Now, question. This is equation number 2. Now next step you have to subtract 2 minus 1. So equation number 2 minus equation number 1. Now we have to subtract, okay, 100x minus x. So 100 into x is 100x, right? We have to subtract 2 minus 1. 100x minus x. Okay, 100x minus x is equal to here 305.25252, okay, dot dot, minus 3.05252, okay, dot dot dot. Now 100x minus x will be getting us 99x is equal to, right? So now this is not pure repeating decimal. After the decimal point, it will not be 0. Okay, you have to subtract 2 minus 2 0. 5 minus 5 0. 2 minus 2 0. Okay, so next 5 minus 5 0. But here 2 minus 0 is 2 is coming. Okay, 2 is coming. And 305 minus 3 is, you will be getting 302. Okay, 302.2. Okay, 302.2 is coming. Actually, here we are getting as decimal. Just convert this decimal in the form of p by q. First 99x, right? As here we have one decimal part, just divide by 10. So it will become a p by q format. Okay, whole number 302 2 just divided by 10. Okay, for removing the decimal, I am just dividing by 10. Okay, now you can just take this 99 to this side. 99 if you are taking to this side. Now x is equal to 3022 divided by 99 into 10. Okay, so you'll be getting us 3022 just divided by 990. So both can be simplified. Okay, both can be simplified, right? So if you are just simplifying it, okay, simplified answer you can write. So just divide by 2 table. 1 2s are 2, balance 1, 5 2s are 10, 1 2s are 2, 1 2s are 2. Just divide by, okay, 4 2s are 8, balance 1, 9 2s are 18, balance 1, so 5 2s are. So now x is equal to, right, 1511 just divided by 495. So we have written in the form of P by Q. Question number 4. Question number 4 is given that, okay, 1.235. Here 35 alone is repeating. 35 alone is repeating. As two digits are repeating, so we have to multiply by 20. That is 100. First step, take let x is equal to 1.235 dot dot dot. Two digits are repeating, just multiply by 100 on both the sides. Okay, on both the sides. If you are multiplying by 100, 100 into x is 100x. If you are multiplying by 100, the decimal will move towards right side 2 place. So you will be getting 123.5 35. So make sure that after the decimal point, we should have equal number of decimal point. Here 3 means here also should be 3. Next, 2 minus 1. 2 minus 1, just subtract 100x minus x. Okay. And 123.535 minus 1.235. 100x minus x is 99x. If you are just subtracting this as 122.3. We are just removing the decimal point. How will you remove the decimal point? We have only one decimal point, just divide by 10, as we have done in the previous question. Next step, you just take this 99 to this side. So 99 into 10 is 990. If you can able to simplify, you have to simplify it. Otherwise, this is the final answer. The same as this question. Okay, fifth question 0.23. Okay, 23 is repeating. Two digits are repeating. Multiply by 20, that is 100 on both sides. If you multiply by 100, it will become 100x is equal to 23.23. So make sure that after the decimal point, we should have two digits. Here also two digits. Then subtract 2 minus 1. 100x minus x is 99x. 23.23 minus 0.23 is 23. Take this 99 to this side. So 23 by 99. Okay, balance all the questions are same. Here, sixth one, 2.05. 5 alone is repeating. Okay, be careful with the bar. 5 alone is repeating. Only one digit is repeating. So multiply by 10. Okay. So 10 into x is 10x. If you're multiplying by 2, 2.05, it will become 20.55. So after the decimal point, we should have two decimal part. Now we subtract 2 minus 1. We are getting as 18.5. So removing the decimal point, just divide by 10. Next step, just take this 9 to this side. So it will become 90. It can be simplified with 5 table. If you are just simplifying with 5 table, 37 by 18. Seventh question, 2.12 bar. Okay, only 5 is repeating. One digit is repeating, multiply by 10 on both the sides. Then subtract 2 minus 1. Here as we have 19.13. So 2 decimal part divided by 100 to make it as whole number. Take this 9 to this side. So 9 into 100 is 900. Same like 8th question, 3.125. Okay, here only one digit is repeating. Just multiply with 10 on both the sides. You will be getting equation number 2. Subtract 2 minus 1. Okay, you will be getting x is equal to 2813 by 900. The last question, 9th one, 2.162 by. So here 4 digits are repeating. So we have to multiply by 4 zeros. That is 10,000. 4 zeros, 10,000. Multiply by both the sides. Make sure that after the decimal point, we should have equal number of decimal part. We should have equal number of decimal part. So after the decimal point, here we have 4 digits. Here also we are having 4 digits. Now subtract 2 minus 1. Okay. 2 minus 1. So 10,000 minus x. We will be getting 9,999. X is equal to, just subtract. We are getting 21,623. 9,999 to this side, so it will become a division. So the answer is x is equal to 21,623 divided by 9,999. Question number 4. Here is given, locate the following rational numbers on the number line. So we already locate, right? So rational numbers is in the form of p by q on the number line. So now here they have given in the form of decimal. They have given the decimal. So we have to represent this numbers on the number line. Okay. So some different way is that, but whatever is easy, I have taken to you. First, you have to identify the given number is belongs to which two interval. You have to find out the interval. For example, here is given 0.532. Okay, it lies in between, so we can just, it will be lies in between 0.530, okay, to 0.540. We can just easily identify this 532. If you are just taking, it will be lies in between 530 to 540. So that I have to take the number line starting from, the starting point is 0.530, the ending point is 0.540. Okay, starting and ending we know. Now we can just draw the number line. Okay, so draw the number line and plot the point. I will be just showing the answer here. First, draw the number line starting from 0.53530 and ending with 0.540. So make 10 equal parts. If you are just taking as 530, 531, 532, 533, 34, 35, 36, 37, 38, 39, then 40. So now we have to mark 0.532. Okay, this is 531, 532. Okay, now this is our answer. Okay, we have to mark this. The next one is 1.5 bar. Bar means the 5 is repeating. Okay, 4 is nothing but, right? So this is nothing but 1.155, etc. So for this, we have to find out the starting point, right? So we cannot just mark the exact location. Okay, exactly we cannot mark. Okay, approximately we can just go with, right? 1.155. So I'm just taking the starting point is 1.550 to 1.560. Okay. So in between, we can just mark this. For example, 55 means it will be lines in between 50 to 60, right? So I'll be just drawing the number line. Okay. So draw the number line and starting from 1.1550 to 1.1560. Make it as 10 equal parts. Mark it as, this is, we are just taking as 50 means 51, 52, 53, 54, 55. Now you have to mark 1.1555. Okay, so you can just mark this one. Okay, this is the one of the way to represent. Question number 5. Find 6 rational numbers between 3 and 4. We already learned, right, rational numbers between any two rational numbers, that is, there are infinitely rational numbers. There are infinitely rational numbers between any two rational numbers. Here they are asking 6 rational numbers. Okay, so we know that there are infinitely many rational numbers in between any two rational numbers, right? If they are asking 6 rational
Yes.
number means we know the rule, so we have to multiply with the next number. Okay, 6 means you have to find out 6 plus 1, that is 7. So we have to multiply and divide with 7 to get 6 rational numbers. Okay, so you don't think that 3 and 4, there is no denominator. I already said all the numbers are having the invisible denominator as 1. 3 can be written as 3 by 1. 4 can be written as 4 by 1. Now this is in the form of P by Q. Right, so I have to find out 6 rational numbers in between. So first I'm just writing 3 as 3 by 1. Okay, so I have to find out 6 rational number. So I can just multiply with 7 by 7. Okay, I'm just multiplying with 7 by 7. So I'll be getting 3 sevens are 21 divided by 1 sevens are 7. The same way is 4 by 1. 4 by 1. I have to multiply with 7 by 7 is equal to 4 sevens are 28 just divided by 7. And they are asking 6 rational numbers. So I can just write, therefore, 6 rational numbers. Okay, 6 rational numbers are, so we should not include 21 by 7 and 28 by 7. So except these two we have to write. So 22 by 7, 23 by 7, 24 by 7, 25 by 7, 26 by 7. Okay, so you can just take it as 27 by 7. So we got 6 rational numbers. Here, question number 6. Find 5 rational numbers between 2 by 5 and 3 by 5. So here also the same. They're having the same denominator as they're asking 5 rational numbers. We have to multiply by the next number, that is 5 plus 1 is 6. So I have to multiply and divide with 5 plus 1, that is 6. Right, so you can just take it as 2 by 5. Okay, so 2 by 5, just multiply and divide with 6 by 6. So 2 3s are, so 2 6 are 12, divided by 5 6 are 30. Next one is 3 by 5. I have to multiply and divide with 6 by 6. 3 6 are 18 by 5 6 are 30. Now I can just find out 5 rational number. Okay, 5 rational numbers. So 5 rational numbers are 13 by 30. Next one is 14 by 30. 14 by 30. Next 15 by 30. 16 by 30. 17 by 30. Question number 7. Find 5 rational number between 1 by 6 and 2 by 5. So here the denominators are not same. Directly we should not multiply with 6 by 6. You will not get the correct answer. First step we have to make the denominator same. Then we have to go with the process. Right? Here first I have to take the LCM for 6 and 5. Okay, LCM of 6 comma 5. As one of the number is a prime number, so LCM will be the product of the number 6 and 5. 6 5s are 30. Now LCM is 30. So I have to make the denominator as 30 first. I can just take 1 by 6, right? I have to check what should I multiply with 30. So 6 5s are 30. The same 5 should be multiplied with numerator. Now I'll be getting 1 5s are 5, just divided by 5 6, 6 5s are 30. Now 5 by 30. Next one is 2 by 5. So 2 by 5, I have to check what should I multiply. So 5 6 are 30. So 2 6 are 12. Okay, 2 6 are 12 by 5 6 are 30. They are asking 5 rational numbers. Okay, first you check whether we can find out, okay, 5 rational numbers in between, except 5 by 30 and 12 by 30. After 5 by 30, 6 by 30, 7 by 30, 8 by 30, 9 by 30, next 10 by 30. Yes, we are getting 5 rational numbers. In this case, again, you no need to multiply by 5 plus 1, 6. Okay, that is not necessary. In between these two itself, now we are getting the, okay, 5 rational numbers. Therefore, we can just write, okay, 5 rational numbers are, okay, 5 rational numbers are, 5 rational numbers are, except 5 by 30, we have to write as 6 by 30, 7 by 30, 8 by 30, 9 by 30, 10 by 30. So we got 5 rational numbers. Now question number 8. If x by 3 plus x by 5 is equal to 16 by 15. Find the rational number x. So we have to find out the value of x. This is nothing but solving, okay, or solving the fraction or solving the rational numbers. So we have to find out the value of x. Right? First I'm just writing the question here. So it's given as x by 3 plus x by 5 is equal to 16 by 15 is given. By seeing itself, I can just say for both are having the x is same. X is having the common number. Now for both are having x is the common factor. Okay, I can just take, right, x is outside. So if I just take x is outside, so here we'll be having 1 by 3 plus 1 by 5. Okay, now is equal to 16 by 15. 16 by 15. Now we can just simplify the bracket by taking LCM, or you can go with the butterfly method. Okay, instead of taking LCM, butterfly method, it will be easy. Now x into, so now multiply the denominator. So 3 5s are 15 and do the cross multiplication. 1 5s are 5 plus 1 3s are 3. This is called as butterfly method, cross multiply. Now this is equal to 16 by 15. Okay. Now just simplify x into 5 plus 3 is 8 by 15 is equal to 16 by 15. Now if I take one fraction to the another side, okay, now x is equal to 8 by 15. If I take it to this side, it will become a reciprocal 15 by 8. Okay. Now 16 by 15 in this right hand side. If I take 8 by 15 to this side, it will become 15 by 8. 15 by 8. Now I can cancel 15, 15 get cancelled. 1 8s are 8, 2 8s are 16. Now x is equal to 2 is the answer. X is equal to 2.